Hello everyone, welcome to V4. I am Kamal. In the number system series, we are continuing with factorials. Today we are going to discuss about questions based on highest powers in factorials. So in this video, first we are going to discuss about basics, how to find highest factorial, and then we are going to solve 7 questions in this video. This is what we are going to discuss in this video. Let us start our video. So first we'll start with basics. What is meant by highest power? Okay, what is meant by highest power? Questions based on factorial. So let us consider an example. So I want to find the highest power of 2 in 5 factorial. If I expand this 5 factorial, what is the power that is highest for 2 I will get? So I can expand 5 factorial as 1 into 2 into 3 into 4 into 5. So I can rewrite this as 1 into 2 into 3 into, instead of 4 I can write it as 2 square into 5. Base as m, I can add the power, eventually it will become 2 cube into 3 into 5. So this is what the prime factorization of this particular number 5 factorial, which is equal to 2 cube into 3 into 5. So once this is done, I can see the highest power of 2 here is 3. So answer for this question is 3. So since it is a small number 5 factorial, I can expand, I can prime factorize this number and then I can find answer. What if the number is so big? For example, 14 factorial, I have to find the highest factor of highest power of 2. So prime factorizing 14 factorial, it will take more time. In order to solve and make it easy, there is a way that is nothing but successive division. Using that successive division, we can do it directly. So using successive division, we can directly do. So basically, what is made successive division means? So dividing multiple times, by taking quotient, quotient alone. So for example, if I want to find 2 power in 5 factorial, what I will do means, first I will divide 5 by 2. My quotient is 2 because 2 2s are 4. Again, if I divide 2 by 2, my quotient is 1. Then highest power of 2 in 5 factorial, which is equal to, just add the quotient alone, 2 plus 1, which is 3. You can see this here. So for example, in 14 factorial also we can do that. 14 factorial, I have to find the highest factorial, which means 14 by 2. My quotient is 7 because 7 times of 2 it can be goes with 14. Again, I will divide 7 by 2. What is the quotient? If I divide this is 3. Again, 3 divided by 2. My quotient is 1. The highest power is nothing but 7 plus 3 plus 1. 7 plus 3 is 10. 10 plus 1 is 11. So 11 is my highest power of 2 in 14 fact. This is how we find the using successive division. So now here we discuss for prime number. For composite number, it is completely different way we are going to find the highest power. For composite number, first we have to prime factorize, okay, and then find individual power value. This is first, this is my second, and this is my third individual power value. Finally, my highest power is nothing but least common value. For example, if I want to find 6 highest power of 6 in 12 factorial. How to do that? Instead of dividing 12 by 6, what I have to do means I have to prime factorize 6. 6 equal to 2 into 3. So I have to find the highest power of 6, highest power of 2 in 12 factorial, highest power of 3 in 12 factorial, And out of these two highest powers, I have to take the least common highest power. Let me explain that. First, 12 by 2, my quotient is 6. Again, 6 by 2, my quotient is 3 because 2 3s are 6. Again, 3 by 2, my quotient is 1. So, highest multiple of 2, which is less than 3 is 2. So, the 2 is nothing but 2 1. So, that's why my quotient is 1. So, the power is nothing but 6 plus 3 plus 1. 6 3s are 9, 9 plus 1 is 10. Again, 12 by 3, my quotient is 4. 4 by 3, my quotient is 1. Just add it. 4 plus 1 is equal to 5. Here, in order to make 1 6, I require 1 2 and 1 3. But here I have only 5 threes and 10 twos. From this, what I can say is using these 5 threes and taking 5 twos from here, I can make 5 6, which means 6. Highest power of 6 in this 12 factorial is 6. This is one way of combining the value. Otherwise, out of these two powers, you just need to take the highest common power. Here, the highest power, sorry, common power is 5. So, not highest, it's the lowest common power. The lowest common power is 5. So, 5 is my answer. This is the second way of doing this. I hope you understand how to uh, find the highest power for both composite and prime. Now let us start solving the question. This is the first question of this video. The question is, we have to find the highest power of 12 in this given expression. So from 137 into 138 into 139 from 283. So if I product all these numbers, what is the highest factor of 12 I will get? This is what I need to find. Here the question is, I know using successive division, for example, if I, in n factorial, so I want to find 12, which is nothing but 2 square into 3. I can find the value. But here, instead of starting from 1, factorial starts from 1 and we multiply all the consecutive terms from 1 to n, and using that only successive division we can apply for factorial. But here it is not a factorial. Then how to find the answer? So what we are going to do means, first we are going to find the highest power of 12 in 283 factorial. Here the highest power of 12. With this, if I subtract the highest power of 12 from first to 136 factorial, I will get the highest power of 12 for these numbers in this question. So from 283, I will find the highest power of 2 square and 3. First, so instead of finding it for 2 square, first you need to find highest power of 2 in the power. I will divide by 2 so that I will get highest power of 2 square. Don't divide by 4 directly here. That's the problem here. So first I will take this. I will find the highest power for 2 square and 3. So 283 by 2. What is my quotient? It is 1, 4, again 1. 141 divided by 2. My quotient is 70. Again 70 by 2. My quotient is 35. Again 35 by 2. My quotient is 17. Again 17 by 2. My quotient is 8. 8 by 2. My quotient is 4 and 4 by 2. My quotient is again 2. 2 by 2. My quotient is again 1. So the highest power of 2 here is 141 plus 70 plus 35 plus 17 plus 8 plus 4 plus 2 plus 1 and just add it. 141 plus 70 is 221. 221 plus 35 is 256. 256 plus 17 is 263. 263 plus 10 is 273. 273 plus 273 plus 2 is 275. 280 and 288. This is sum. So highest power of 2 is 288. Now I have to convert this into 2 square. 2 square power. If I divide this 288 by 2, which is nothing but 144. The highest power of 2 square is 144. Now we will do for 3 now. So 283 by 3. My quotient is uh, 9s are again 4s are 94 by 3. My quotient is 3s are 1s are. In 31 by 3, my quotient is 10. 10 by 3, my quotient is 3. 3 by 3, my quotient is 1. Just add everything. 94 plus 31 plus 10 plus 3 plus 1. 94 uh, plus 31 is nothing but 125. 125 plus 10 is 135. 135 plus 4 is 139. From what is the highest common factor? 139, 144, which is 139. The highest power of 12, which is nothing but 139 in 283 factorial. Now I have to find the same thing for 136 factorial. So 136 by 2, my quotient is going to be 68. 68 by 2, my quotient is going to be 34. And 34 by 2, my quotient is going to be 17. 17 by 2, my quotient is going to be 8. 8 by 2, my quotient is going to be 4. And 4 by 2, my quotient is going to be 2. 2 by 2, my quotient is going to be 1. Just add everything. 68 plus 34 plus 17 plus 8 plus 4 plus 2 plus 1. 68 plus 32, 72, 102, 102, 119, 119, 120, 130, 134. The highest power of 2 in 136 factorial is 134. So 134 by 2, which is nothing but 6 or 7, sir. So the highest power of 2 square in 136 factorial is nothing but 67. Now we will do for 136 for 3. Quotient is going to be 4s are 5s are again 45 by 3. My quotient is going to be 15. Again 15 by 3. My quotient is going to be 5. And 5 by 3. My quotient is going to be 1. Just add everything. 45 plus 15 plus 5 plus 1. So 68, 65, 66. The highest common power between these two is 66. The highest power of 12 in 136, 66. Just take the difference. So the difference is 139 minus 66, 3 again 7, 73. 73 will be my answer for this question. The highest power of 12 from 137, product of all the consecutive terms from 137 to 283 is 73. This will be my answer. I hope you understand this question. Now we'll go to next question. I need to find the highest power of 98 in 99 in this different 99 factorial minus 98 factorial. So I know 99 factorial is nothing but 99 into 98 factorial, which means I can rewrite this as 99 into 98 factorial minus 98 factorial. If I take the common 98 factorial outside, will become 99 minus 1, which is equal to 98 factorial into 98. So I know the highest power of 98, here it is 98 alone, which is 1. But I don't know what is the highest power of 98 here. So I need to divide, first I need to factorize the 98 to find the highest power of 98 in 98 factorial. 98 is nothing but 49 into 2, which is 7 square into 2. So now I need to find the highest power of 7 square in 98 factorial and the highest power of 2 in 98 factorial. One important thing you should remember here is, I know definitely my final answer will be the common smallest common power between 7 square and 2. 7 square powers and 2 square powers. Okay. So here the thing is, definitely I can say 7 squares power is going to be the least comparatively 2 powers, which means instead of finding the 2 powers value, I can just focus alone to find the 7 square powers alone. I don't need to find the 2 powers because 2 powers value is definitely going to be more than the 7 square powers. So either way my final answer is going to be the least power among these two. So that definitely it's going to be 7 square powers. That's why I'm going to just find the 7 squares power. So if I divide 98 by 7, what will be my remainder? It's going to be 14 times, again 14 by 7. My quotient will be 2. So 2 is less than 7. So um, the highest power of 7 square, 7 is nothing but 16. But I want to find power 7 square, which is nothing but 7 square whole power 8. So highest power of 7 square in 98 factorial is 8, which means in 98 factorial, the highest power of 98 is 8. And here it is 98 factorial into 98, which means I have one more equal, which is nothing but 98 power 9. So the answer for this question is going to be, I hope you understand this question also. Now let us go to next question now. What is the highest power of 5 that will divide the product of first 50 multiples of 5? So 5 ones are 5, we have to do up to 5 fifties are 2500, which means 5 into 10 into 15 into this product is keep on goes up to 2500. That's the first step. Second step is I will need to find the highest power of 5. So I know if I can able to convert this number into certain factorial using successor division, I can able to find the highest power of 5 here. So here I can write this 5 as 5 into 1 and 10 as 5 into 2 and 15 as 5 into 3 and keep on goes up to this 2500 as 5 into 50. So I have 5 written in multiples of I multiplied 5 50 times. So all the if bases are same, I can add all the powers. Eventually it will become 5 power 50 into 1 into 2 into 3. Keep on goes up to 50. If I write product of all the consecutive natural numbers from 1 to 50, this is nothing but 5 power 50 into 50 factorial. I already found the 50 power 5 power 50. I need to find the highest power of 5 in 50 factorial. It's nothing but 50 factorial by 5. The quotient is going to be again 10 by 5. My quotient is going to be 2. The highest power of 5 in 50 factorial is 10 plus 2 is 12, which is nothing but 5 power 12. So if you multiply these two, it will become 5 power 50 into 5 power 12. Since both are same, I can add the power. 50 plus 12 is 62. So 5 power 62. So in this product of first 50 consecutive multiples of 5, the highest power of 5 is 62. That's my answer. I hope you understand this question. Now let us go to next question now. The highest power of 2 in 10 factorial plus 7 factorial plus 12 factorial plus 13 factorial up to 1000 factorial. This is an easy question, similar to the question which we discussed here, not here, here. So find, so here, find highest power of 2 from 2 factorial, right?